Now that we've covered key concepts related to Agoric's smart contract framework, let's dive into the core components and basic concepts specific to the Agoric platform. This section will help you understand the fundamental building blocks that you will use when developing applications on Agoric. Here's an overview of the basic concepts that we'll cover. We'll begin by looking at mints, which are unique sources of digital assets and have the authority to create new purses and payments of a specific brand. We'll then discuss what purses are. Purses hold balances of digital assets that are created by a specific mint. Purses can receive deposits and make withdrawals. Next, we'll talk about payments, which are units of digital assets created by a mint that can be transferred between purses or used in smart contract transactions. Next, we'll talk about issuers, trusted authorities that validate mints and purses, ensuring the integrity of digital assets. Then we'll define amounts. Amounts represent quantities of digital assets, and we'll talk about how amounts are used in transactions. We'll cover brands, which are identifiers that distinguish different types of digital assets, ensuring clarity and consistency. We'll discuss offers, proposals for transactions, and the concept of offer safety, which ensures that participants get what they expect from a transaction. We'll look at the Zoe Service, which is crucial for deploying and managing smart contracts on the Agoric platform. We'll explain seats, which are used by contracts and users to access or manipulate offers, playing a key role in contract interactions. And finally, we'll discuss the Zoe Contract Facet, or ZCF, an API for running a contract instance that facilitates interactions with the contract. By understanding these basic concepts, you'll have a solid foundation for working with the Agoric platform and developing sophisticated smart contracts and applications. We'll go through each of these components in detail, starting with mints. Let's begin with a detailed look at mints. In Agoric, a mint is a key component responsible for creating and managing digital assets. A mint is essentially the unique source of digital assets within the Agoric ecosystem. It is the entity that creates new units of a particular type of digital asset. The assets created by a mint are always associated with a specific brand. This helps to distinguish and manage different types of assets. Let's talk about the authority that mints have and the functions that they can perform. Mints have the authority to create both payments and purses. These are the primary functions of a mint. Let's break this down further. A mint can create new purses. A purse is like a digital wallet that holds a balance of the asset created by the mint. Purses are used to store and manage these assets securely. A mint can also create payments. Payments are the units of the digital asset that can be transferred between purses or used in transactions. Payments are designed to be temporary and are often used for specific transactions or transfers. To make this all a bit more concrete, let's consider an example of a stablecoin mint. Imagine we have a mint that creates a stable coin called USD coin. This mint is the only source that can create new USD coins. The USD coin mint is associated with the USD coin brand. When the mint creates a new purse, it initializes it with a certain balance of USD coins. For instance, a purse might be created with 100 USD coins. The mint can also create payments. For example, it might create a payment of 10 USD coins that can be used to buy goods or services. In this example, the USD coin mint ensures that all USD coins in circulation are valid and accounted for, providing trust and stability in the ecosystem. Mints play a crucial role in the Agoric platform by ensuring that digital assets are created and managed securely and efficiently. Understanding how mints work is fundamental to building and interacting with smart contracts in Agoric, as they are the backbone of asset creation and management. Next, we'll look at purses, which are closely related to mints and are essential for managing digital asset balances. Let's explore the concept of purses in the Agoric ecosystem. Purses are essential for holding and managing balances of digital assets created by mints. A purse is an object that holds a balance of digital assets. Think of it as a digital wallet specifically designed to store assets created by a mint. Each purse is associated with a particular brand, ensuring it only holds one type of asset. For example, a purse might hold USD coins or tokens representing a specific digital asset. Purses support two main operations: receiving deposits and making withdrawals. Let's delve into these operations. A purse can receive deposits of digital assets. When a payment is sent to a purse, the assets in the payment are added to the purse's balance. For example, if you have a purse holding USD coins and you receive a payment of 10 USD coins, the balance of your purse increases by 10 USD coins. A purse can also make withdrawals. When you withdraw an asset from a purse, a new payment is created representing the withdrawn assets. For example, if you withdraw 5 USD coins from a purse, a payment of 5 USD coins is created, and the balance of the purse decreases by 5 USD coins. To illustrate how purses work, let's consider an example of managing a purse for USD coins. Suppose that you have a purse that initially holds 100 USD coins. This is your starting balance. You receive a payment of 20 USD coins from a friend. You deposit this payment into your purse, increasing the balance to 120 USD coins. Later, you decide to buy an item that costs 30 USD coins. You withdraw 30 USD coins from your purse, which creates a payment of 30 USD coins for the purchase. The balance of your purse is now 90 USD coins. This example demonstrates how purses allow you to securely manage your digital assets by receiving deposits and making withdrawals. Understanding how purses work is crucial for effectively managing digital assets in Agoric. They provide a secure and efficient way to handle balances and transactions. Next, we'll discuss payments, which are closely related to purses and play a key role in transactions within the Agoric ecosystem. Now let's dive into payments, another essential concept in the Agoric ecosystem. Payments are units of digital assets created by a mint and are used for transferring and transacting these assets. A payment is a transferable unit of digital assets that a mint creates. Unlike purses, which hold and manage balances, payments are designed for movement between entities or for use in transactions. Payments are temporary and intended for specific purposes, such as making purchases or transferring assets to another user. Payments have two primary uses: transferring assets between purses and engaging in smart contract transactions. Let's break these down. Payments enable the transfer of digital assets from one purse to another. When a payment is created from a purse, it represents a specific amount of the asset that can be sent to another purse. For example, if you want to send 10 USD coins to a friend, you create a payment of 10 USD coins from your purse and then transfer it to your friend's purse. Payments are also used in transactions with smart contracts. When interacting with a smart contract, you often need to provide a payment as part of the transaction proposal. For example, if you are participating in a decentralized auction, you might place a bid by sending a payment of your bid amount to the auction contract. To illustrate the use of payments, let's consider an example of using payments in transactions. Suppose you have a purse with a balance of 100 USD coins. You decide to buy a piece of digital art that costs 25 USD coins. You create a payment of 25 USD coins from your purse. This payment represents the amount that you are willing to spend on the artwork. You send the payment to the seller's smart contract. The contract verifies the payment and transfers ownership of the digital artwork to you. The payment is then deposited into the seller's purse, and your purse balance decreases by 25 USD coins, leaving you with 75 USD coins. This example demonstrates how payments facilitate transactions by transferring specific amounts of digital assets securely and efficiently. Payments are a fundamental part of the Agoric ecosystem, enabling the movement and transaction of digital assets in a secure and controlled manner. Next, we'll look at issuers, which play a critical role in validating and managing digital assets within the Agoric platform. Let's talk about issuers. Issuers are critical components in the Agoric ecosystem for managing and validating digital assets. An issuer is a trusted authority that validates and manages mints and purses. It ensures the integrity and authenticity of the digital assets created and transferred within the Agoric platform. Issuers are responsible for overseeing the creation, validation, and transfer of assets, ensuring that these processes are secure and reliable. Issuers have several key responsibilities that are essential for maintaining the trust and functionality of the Agoric ecosystem. One of the primary roles of an issuer is to ensure that the digital assets created by a mint are authentic and valid. This involves verifying that the assets comply with the rules and standards defined for the specific brand. For example, if a mint creates USD coins, the issuer ensures that these coins are correctly issued and that their quantity is accurately recorded. Issuers also manage the transfer of assets between purses and payments. They validate and authorize these transfers, ensuring that they are legitimate and adhere to the contract's rules. For instance, when a payment is made from one purse to another, the issuer verifies the transaction to ensure that the correct amount is transferred and that both the sending and receiving purses are accurately updated. To illustrate the role of issuers, let's consider an example of how issuers function in a transaction. Suppose that Alice wants to send 50 USD coins to Bob. Alice creates a payment of 50 USD coins from her purse. The issuer verifies that the payment is valid and that Alice's purse has sufficient balance to cover the payment. Once the issuer validates the payment, it authorizes the transfer. Bob's purse receives the 50 USD coins and Alice's purse is updated accordingly. The issuer ensures that the transaction is completed correctly, maintaining the integrity of the asset transfer. In this example, the issuer acts as a gatekeeper, verifying and validating each step of the transaction to ensure that the assets are transferred securely and accurately. Issuers play a crucial role in the Agoric ecosystem by providing validation and security for digital asset transactions. They ensure that assets are authentic and that transfers are executed correctly, maintaining trust and reliability in the platform. Next, we'll discuss amounts, which represent quantities of digital assets and are essential for defining and managing transactions. Now let's discuss two key concepts in the Agoric ecosystem: amounts and brands. These concepts are essential for defining and managing digital assets. An amount represents a specific quantity of a digital asset. It is a fundamental concept used in transactions to specify how much of an asset is involved. Amounts are always associated with a brand, which ensures that the quantity is clearly defined and that there is no ambiguity about what asset is being referenced. A brand is an identifier that distinguishes different types of digital assets. Each brand is associated with a specific mint and the asset it creates. Brands help ensure clarity and consistency in transactions as they specify the type of asset being referenced. For example, the brand USD coin distinguishes USD coins from other digital assets like gold token or silver token. Let's consider an example to illustrate how amounts and brands are used together. Suppose you have a purse holding USD coins. The brand for these coins is USD coin. You want to make a payment of 30 USD coins. Here, 30 is the amount and USD coin is the brand. When you create a payment of 30 USD coins, the amount specifies the quantity and the brand ensures that there is no confusion about which asset is being transferred. In another scenario, you might be dealing with a different asset, like gold token. If you want to transfer 5 gold tokens, the amount is 5 and the brand is gold token. By clearly defining both the quantity and the type of asset, amounts and brands help to maintain accuracy and trust in transactions. Amounts and brands are crucial for all operations in the Agoric platform, from simple transactions to complex smart contract interactions. They provide a clear and consistent way to define and manage digital assets. Next, we'll discuss offers and offer safety, which are essential for ensuring secure and reliable transactions within the Agoric ecosystem. Next, let's talk about offers and offer safety, which are critical components for ensuring secure and reliable transactions in Agoric. An offer is essentially a proposal for a transaction. When you make an offer, you specify what you are willing to give and what you expect to receive in return. Offers are central to how users and contracts interact in Agoric. They allow participants to propose exchanges of assets in a structured and secure manner. Offer safety is a guarantee provided by the Agoric platform to ensure that participants in a transaction get what they expect. It means that an offer will either be fully accepted and completed as proposed, or it will be rejected and no changes will occur. This guarantee is crucial for maintaining trust and reliability in transactions. It ensures that users can participate in the system with confidence that they will not be unfairly treated or lose assets unexpectedly. Let's consider an example to illustrate how offers and offer safety work. Suppose that Alice wants to buy digital artwork from Bob for 50 USD coins. Alice makes an offer to Bob's smart contract, specifying that she is willing to pay 50 USD coins in exchange for the digital artwork. Bob's smart contract reviews the offer. If the offer meets the contract's terms and conditions, it is accepted. The transaction is completed. Alice receives the digital artwork, and Bob receives the 50 USD coins. If the offer does not meet the terms, it is rejected, and no transaction takes place. Alice retains her 50 USD coins, and the digital artwork remains with Bob. In this example, offer safety ensures that Alice either gets the digital artwork for her 50 USD coins or retains her assets if the offer is not accepted. This prevents any unexpected loss of assets or incomplete transactions. Understanding offers and offer safety is crucial for interacting with smart contracts in Agoric. They provide a structured way to propose and complete transactions while ensuring that all parties are protected and receive the expected outcomes. Next, we'll explore the Zoe Service, which is a powerful tool in Agoric for deploying and managing smart contracts. Let's dive into the Zoe Service, a fundamental component of the Agoric platform that simplifies the deployment and management of smart contracts. The Zoe Service is a framework within Agoric that facilitates the secure creation, execution, and management of smart contracts. It abstracts much of the complexity involved in handling contracts, making it easier for developers to focus on contract logic. Zoe ensures that all interactions with contracts are secure, transparent, and reliable, adhering to the principles of offer safety that we discussed earlier. Zoe has several core functions that are essential for managing smart contracts. contracts. Zoe allows developers to create instances of smart contracts. An instance is a specific deployment of a smart contract that users can interact with. When you deploy a contract using Zoe, it creates a new instance with its own state and parameters. This instance can then be used to handle offers and transactions. One of Zoe's key roles is to manage offers made to contract instances. It receives offers from users, ensures they meet the contract's terms, and then processes them accordingly. Zoe facilitates the entire life cycle of an offer, from submission to acceptance or rejection, ensuring that all operations are handled securely and efficiently. Zoe enforces offer safety, ensuring that offers are either fully executed as proposed or rejected without any changes. This provides a secure and predictable environment for transactions. Let's walk through an example of how Zoe is used to deploy and manage a contract. Suppose you want to deploy a simple auction contract. You write the contract logic in JavaScript, defining the rules for submitting bids and selecting the winner. You then use Zoe to create an instance of the auction contract. Zoe handles the deployment, initializing the contract with the necessary state and parameters. Users who want to participate in the auction make offers through Zoe. They submit their bids, specifying the amount that they are willing to pay. Zoe manages these offers, ensuring they meet the contract's rules. It tracks the highest bid and updates state accordingly. At the end of the auction, Zoe processes the offers, ensuring that the highest bidder's payment is accepted and the digital item is transferred to them. All other bids are rejected and their assets are returned. In this example, Zoe simplifies the deployment and management of the auction contract, handling all interactions securely and efficiently while ensuring offer safety. The Zoe Service is a powerful tool that enhances the functionality and security of smart contracts on the Agoric platform. By leveraging Zoe, developers can create robust and reliable contracts that users can interact with confidently. Next, we'll discuss seats, which are essential for interacting with and managing offers within the Zoe service. A seat is an abstraction used in Agoric to represent a position within a contract where users or other contracts can sit to perform actions. It serves as an interface for interacting with the contract, allowing users to make offers, receive payouts, and track the status of their interactions. Seats are typically used to manage the flow of assets and information between users and the contract, ensuring that all operations are handled securely and transparently. There are two primary types of seats in Agoric: user seats and contract seats. User seats are used by individuals or external entities to interact with a contract. When a user makes an offer to a contract through Zoe, they receive a user seat. This seat provides methods for checking the status of the offer, retrieving payouts, and withdrawing from the contract. For example, if Alice makes an offer to participate in an auction, she receives a user seat. This seat allows her to track her bid status, retrieve her item if she wins, or get her funds back if she loses. Contract seats are used internally within a contract to manage and process offers. These seats allow the contract to handle multiple offers, execute contract logic, and ensure that all interactions comply with the contract's rules. For instance, in an auction contract, a contract seat might be used to keep track of the highest bid and manage the transfer of the item to the winning bidder. To illustrate how seats work, let's consider an example of a simple loan contract. Suppose that Bob wants to borrow 100 USD coins from a lending contract. He makes an offer through Zoe, specifying the terms of the loan, including the amount he wants to borrow and the collateral he is willing to provide. Upon making the offer, Bob receives a user seat. This seat allows Bob to track the status of his loan application, see if it has been accepted, and manage his repayments. Meanwhile, the contract itself uses contract seats to handle Bob's offer. It checks the collateral, assesses the terms, and decides whether to accept or reject the loan application. If the offer is accepted, Bob's user seat provides methods for him to receive the borrowed amount and to make repayments. If the offer is rejected, the seat allows Bob to retrieve his collateral. In this example, seats provide a structured way for both Bob and the contract to interact securely and efficiently. Bob's user seat ensures that he can manage his loan, while the contract seat ensures the contract processes the offer according to its rules. Seats are fundamental to managing interactions within Agoric contracts, providing a clear and secure way for users and contracts to engage with each other. Next, we'll discuss the Zoe Contract Facet, or ZCF, which provides the interface for writing and managing contract logic in Agoric. The Zoe Contract Facet, or ZCF, is an API provided by Zoe for running a contract instance. It offers the tools and methods needed to write, manage, and interact with the contract's logic securely and efficiently. ZCF acts as a bridge between your contract code and the Zoe service, enabling your contract to handle offers, manage state, and perform secure transactions. ZCF provides several core capabilities that are crucial for developing robust smart contracts. ZCF allows you to define and manage the state of your contract using familiar JavaScript constructs. You can initialize state variables, update them based on interactions, and ensure they persist across contract calls. For instance, in a marketplace contract, you might use ZCF to track the list of items for sale, their prices, and the current highest bids. ZCF provides methods to interact with the Zoe service, enabling your contract to securely handle offers and manage assets. This includes creating and accepting offers, rejecting offers that don't meet specified criteria, and managing payouts. For example, if your contract involves an auction, ZCF helps you process bids, determine the highest bidder, and handle the transfer of the auctioned item. One of the primary functions of ZCF is to manage offers made to the contract. It allows you to define the conditions under which offers are accepted or rejected and to specify the actions that should be taken when an offer is processed. ZCF ensures that all offer interactions comply with the contract's logic and the principle of offer safety, providing a secure and predictable environment for transactions. Let's consider an example of writing a simple auction contract using ZCF. First, you define the initial state of the contract, such as the item being auctioned and the starting bid. Using ZCF, you set up a method to handle incoming bids. This method checks whether each bid meets the minimum bid requirement and is higher than the current highest bid. When a new bid is received, ZCF updates the contract state to reflect the new highest bid and the corresponding bidder. It also ensures that the previous bidder's funds are securely returned if they are outbid. At the end of the auction, ZCF processes the final highest bid, transferring the item to the winning bidder and the payment to the seller. In this example, ZCF simplifies the process of managing the auction's logic and state, ensuring that all interactions are handled securely and efficiently. By leveraging ZCF, developers can write smart contracts that are both powerful and secure, taking full advantage of Agoric's capabilities to manage assets and interactions. Understanding how to use the Zoe Contract Facet is crucial for developing effective and secure smart contracts on the Agoric platform. Next, we'll conclude this module. Now that we've covered the fundamental concepts and components of the Agoric platform, let's summarize the key points. We started with the basics of smart contracts, including their structure and how they function in the Agoric ecosystem. Next, we discussed the importance of using hardened JavaScript for contract development. We explored how state is managed within Agoric smart contracts and mechanisms for access control. We delved into the process of upgrading contracts using the admin facet and the principles of contract governance. We then moved on to Agoric-specific concepts such as mints, purses, payments, and issuers. And we discussed how they facilitate the creation and management of digital assets. We also covered amounts and brands, which help in defining and managing digital assets, and the principles of offers and offer safety, ensuring secure and predictable transactions. We looked at the Zoe Service, which simplifies the deployment and management of smart contracts, and the role of seats in managing interactions. Finally, we discussed the Zoe Contract Facet, or ZCF, which provides the interface for writing and managing contract logic securely. In the next module, we'll be taking a look at the basics of programming on the Agoric platform.